Good morning children. How are you all? Hope you all are safe at home. Today we are going to learn about computer. What's our lesson name? The computer system. So in the last class we have learned about the different sizes of computers based on different sizes of computers and different types of computers, hardware. So about hardware, in that hardware we have learned about input devices and output devices. So the second part is software. Today we are going to learn about software. So our lesson name is the computer system. In that we are going to learn about software. So software. So hardware means we can touch and feel. Those devices we can see. But software, it is a collection of instructions which are given to work with the computer. So what is a software? It is a term, it is a word used to denote the collection of instructions. That collection of instructions are called as a program. So if you use any language to write any program, that is called as programming language. Okay. So software is a collection of set of instructions or collection of instructions. Collection of instructions. So in this software we have two types. How many types? Two types of softwares. Two types. The first one is system software and the second one is application software. So first is system software. Second is application software. Application software. Okay. So software is a collection of instructions or set of instructions which is called as a program. Next is in this software we have two types of softwares. One is system software and another one is application software. Now we will learn about system software. What is system software? It works like an interface between the user and the computer. Okay, system software. So it works like an interface between the user and the system. That means user and the hardware parts. We can use different hardware devices using this system software. In this system software, we have three types of software. Three types. The first one is operating system. The first one is operating system. So operating system, generally we use that operating system. That is Windows 7. Nowadays, so in our systems we are using this Windows 7 operating system. This is the interface between the user and the hardware and the computer. That means whatever the user gives, that it converts into the machine understandable language and again it gives to the computer. And after that, again it converts the information and it is displayed on the monitor. So you know the work, input output process. So whatever the data is given through keyboard, that processed and stored in the CPU and it is displayed on the monitor. That we know. Same. So this operating system, whenever you switch on your computer, the first thing happens is your operating system is loaded into your computer. So the basic operating system we use is Windows 7. So it is a interface between user and hardware or user and computer. Interface between user and computer. So next one is language processors. Language processor. Processors or translators. Language processors or language translators. Okay. So in this language processor means what I said. So whatever the information you give, that is converted into the machine understandable language. Our machine understands only binary language, that is machine language. Zeros and ones only computer understands. So whatever the information we give, that should be converted into machine language, and after to display that machine language also, it should be converted and displayed on the monitor. So what are the language processors, language translators used in the computer? So something has to needed to convert that language. So from keyboard you are typing letters and numbers. Internally it needs some processor or it needs some translator to convert your information into another form, machine understandable form. So now we will see what are those language processors. We have three language processors. So assembler, interpreter, second one is interpreter, third one is compiler. Interpreter, third is compiler. Compiler. So assembler, this assembler converts the information into machine language. This assembler, whatever you give, that input, it converts into machine language. Machine language. That means zeros and ones. Converts to zeros and ones. Converts here. Converts your input into machine language, into zeros and ones. Next, this interpreter, it also converts your information line by line. So what are the instructions you give, those line by line it will convert the information into machine language. Okay. After removing those errors, that information is displayed on the monitor. Again conversion, again it is displayed. Next, third one is compiler. So this is line by line conversion. It converts line by line and errors are given line by line. Errors given. Okay. So next one is compiler. So this compiler, it is also a language processor. It converts your information, whatever the program you give or whatever the set of instructions you give, that will be converted to the machine language. So at a time it will convert your whole program. At a time it will convert the program into machine language at a time. So and the errors will be given by line. So in that, suppose if you have in fourth line you have error. It gives error in fourth line, line 4, like that. Errors will be given line by line. Errors given by line number. Given by line number. So if in line 4 it is, so line 4 like that, by line number. And write by line number. So after correcting these errors, again it will be converted again and it is displayed on the monitor. Okay? This is about language processors. And the third one is drivers. Driver. So third is a driver. Third one is drivers. So we are working with different hardware parts. What are the different hardware parts we can connect to the computer? Keyboard we can connect, printer we can connect, keyboard, printer, scanner, okay, printer, scanner, mouse. So all these devices we can, and webcams, different hardware devices we can connect to the system. So connected to the system. So whenever you connect these devices, its driver has to be installed into the computer. Whenever its driver installed, that software is installed, then only you can work with this keyboard or with the printer or with that scanner, you can work. Okay. So to work with any hardware device, we have to install the driver into the computer. Then only you can work with those hardware parts. Those are the drivers. Okay. Drivers. So what are the system software? What comes under system software? First one is operating system. Operating system. Second is language processors. Language processors. In this language processors, what are those? What are those assemblers? Next, interpreter. Interpreter. Next, third one is compiler. So, it is operating system is the interface between user and the computer. So, language processors means it converts, it translates the language from English to machine language using different processors. Okay, at a time it can convert, or line by line it can convert, or directly it can convert into machine language. Okay, next third one is drivers. So drivers means if you want to use any hardware devices like keyboard, mouse, scanner, printer, so everything, all those software drivers should be installed into the computer. Then only you can work with those hardware parts. Nowadays we are getting plug and play. Plug and play means directly you can connect and you can work with the devices. Okay, no need to install the drivers into that. Okay, so nowadays what we are using? Plug and play. Plug and play, or you can write plug and play. This type of devices you can use. That means you can plug it and you can play. That means you can use it. No need of installation of any software. Okay. So next, application software. Next is the second one is application software. Second one is application software. So in this application software, we have two types. Okay, one is package, another one is utility. Another one is utility. So package, it is a set of software, set of applications which has different uses. Suppose MS Office. Example is MS Office. So in that we have different applications, isn't it? And in MS Office we have MS Word, MS Access, MS Excel, MS PowerPoint. We have different uses or not? With Word we can type information, and Excel we can write tables, we can do the calculations. And third one, PowerPoint, we can give presentations. Fourth one, Access, that is also for database management. The next, utility, it is one application, the routine application. It is used to do the routine application like WinZip. Zip files to zip files, that is used. Example is WinZip, Windows zip files. Okay, every time you do the routine work. The next one is antivirus. Okay, antivirus software. Antivirus software. What is its work? Every time it has to control the virus. Isn't it? Only one work it is doing, and that is routine work. Those are the utilities. Package means we can use different applications for different purposes. Understood? Next, coming to software, we have different generations. Computer programming languages. Computer programming languages. Now we will learn about these languages. So what we said, to work with the computer, it needs some language to understand, isn't it? Generally we use that English, and we have different programming languages. What is a program? So software is set of instructions. Those set of instructions called as program. Set of instructions. Okay, these are called as program. Okay, whenever you use some language to write that program, that is called as programming language. Okay, programming language. To write those set of instructions, if you use any language, that is called as programming language. We have different programming languages, C, C++, Java, okay, .NET, like that we have different programming languages. Fortran, Basic, all those. Okay. Now we will learn how many generations of programming languages. We are day by day updates. Day by day we are updating and we are inventing new programming languages for our purpose. Isn't it? In that for computers also we have different generations of computers. Isn't it? Like that we have different generations of programming languages. Generations of languages. The first generation language. First one is first generation language. So in this first generation language, only the machine language is used, zeros and ones. What is used? Machine language is used. Machine language is nothing but binary language. Binary codes are used. That is 0 or 1. Only zeros and ones. Those are used. In 5th class we have learned how to convert any information into binary form. Just I will show you one example here. Okay. Let us take 34 base 10 because it is decimal number. We will convert it into binary form. How to convert it into binary form? Divided by 2. 2 17s are 0. 0 is a remainder. 2 how much? 2 8s are 16. Remainder 1. 2 4s are 8. Remainder 0. 2 2s are 4. Remainder 0. Again 2 1s are 0. Okay, na? So this is quotient. This side we have to write quotient and this side we have to write remainder. The numbers you have to write from bottom to top. 1 0. How many zeros? 1 2 3. 2 3 zeros and 1 0. Base 2 because it is binary digit. Okay, like that we have to convert it into binary form. And this is from keyboard and it is in memory. Okay, again from memory to monitor. Memory to monitor. How it is converted? Again this 1 0 0 0 1 0. No, this one we have to convert 2 power 0, 2 power 1, 2 square, 2 cube, 2 4, 2 to the power of 5 like that. That equals to 2 to the power of 5. How much? 2. Multiply 2 5 times. Okay, directly I am writing 1 into 32 because you know. Again I will write. Otherwise I will write it 2 into 2 into 2 into 2 into 2. Okay, into 1 plus 2 to the power of 4 means 16 into 0 plus 2 to the power of 3 8 into 0 plus 4 into 0 plus how much? This one 2 into 2 2. 2 into 1 equals to 2 into 1 plus 2 power 0 1 into 0. That equals to how much it is? 32 plus 2. Okay. What is the answer here? 34. 34 is the base. Like this it is converted and it is displayed on the monitor. That is first generation language. What is used in first generation language? Machine language. So that is binary code. And this is an example how a number is converted into binary form. Again binary form to decimal form. And it is displayed on the monitor. Okay. Next is second generation language. Second one is second generation language. In this second generation language, mnemonic codes are used. Second one is second generation language. So in this, what is used? Mnemonic codes. Mnemonic codes are used to write any program. These codes are used. Okay. So here mnemonic codes is nothing but, suppose if you want to add two numbers, what we have to give? Add. Some small codes are given. Okay, short forms. For subtraction, we can give sum. For multiplication, mul. For division, div. Like this, we can give short forms, different codes for the arithmetic operations. Okay, and we have logical operations also, and or not. Okay, for all those operations only short forms are given. Suppose example, you want to add two numbers, A add B. Okay, so for that you have to read A. Okay, read A or store A. Okay, I am writing read A. Next to read B. So this will be stored in some place in the memory. Okay, B also. This is also stored in some place or registers or some memory. It is stored there. And after that, what happens? Add A comma B. So this A comma B value will be displayed. Okay, after that, print sum or sum is displayed here. You know, like this we will use different mnemonic codes to do any mathematical operations. So this is the example. These are the short forms. Short codes are used to do any operation. Okay, here we don't use any operators. Just these codes will be used. Next, third is the third generation languages. Third generation language. Third generation languages are high level languages. Okay, that also I will show you. Third generation language. In this third generation language, mainly we use English to write any program. Examples are C and C++. C comma C++ we use to write this generation programming. Okay, so example I will show you one program. Same that addition. Same addition. What we have to do in this? First we have to decide the data types. So we don't need this language. Just I am giving for example. So okay, how many we need? A, B and C you can take, or you can write sum, or you can write addition there. Okay, first if you want to enter values, printf. So to print it on the monitor, okay, %d, okay, enter a value. Here enter a value. So a value is entered here. Okay, next that value you are reading. So %d, comma %a. This %a is reading the value for a. Next again printf. Now we need b value. Enter b value. Enter b value. So this value also entered here. That also you are reading. Scanf %d. D for integer. So here I declared now integer value. For that I am giving %d. Okay. Next %b value. Here we are reading b value. After that what? C we have given. C equals to a plus b. Next printf. So that sum we are displaying on the monitor. Sum equals to what it is? Sum equals to %d comma c. Or %d comma c. The c value is given here. Get CH close. So here a value we will enter some 10 a value. Write the output side on the screen, and this is back end. There we will write all this program, and on the screen we will enter this. Only you can see this. While writing you can see this and this. But those who are using this program, they can use this only. Okay. So b value we will enter some 20. What is the sum here? Sum equals to 30. It is displayed. This all displayed on the monitor. So behind we have to write this program in C. Okay. So for example I explained this is the third generation language. So examples are C and C++. I gave one C language example. So like this we can add two numbers and we can display the sum on the screen. Okay. Next one is fourth generation language. So fourth generation language is user friendly. So whatever the output you want, only that you can specify. No need to write any program there. Here in third generation language, what I did, we wrote one program to display that output. But in fourth generation languages, you don't need to write any program here. Fourth generation languages. In this fourth generation language, no need to write any program, no need of program. Okay, just you have to specify whatever the output you want. You can specify the output. Whatever you want, that will be displayed on the screen. How? We will see. So for that, here we use Oracle or SQL structured query language. Okay, in that it comes Oracle. So in this structured query language, we use Oracle. I am giving one Oracle query. Okay. So example is some table. Okay, in Excel we know that table. So we have entered some details in the table. S number, name, S number, S name. Okay, subject 1 and number 1, 2 Excel. In Excel I am giving. Okay, this is in Excel. But I have to create a table in Oracle. Just for example, I am giving this table is in Oracle. Okay, S name is A and name is B. Subject is 50, 60 marks. Like this table I have created. Okay, na? Table we have created. After this, the query. What you have to give? I want this S name where the marks are 50. Where subject marks equals to 50. So for that I am giving one query. So I want to display this name and a number by where the marks are 50 marks. Where are those 50 marks? That record I want to display. Select S number, comma, S name. What I want? S number and S name. Where what it is? Subject 1 equals to 50 marks. So one more we will enter 3. Again here also 50 marks. C. Okay. 50. What are the records will be? So fourth generation languages. Here the structured query language is used. So example is select S number, S name from student where subject 1 equals to 50 marks. In that student table we will display where the marks are greater than equals to 50 marks. So what are those two records we have there? S number, S name. 1 and 3 records and the names are displayed. So this is the fourth generation language. You need to give any question or you not to write any program or anything you should not do. Okay, just what is the problem that you have to mention. All the logic, what are the calculations you need, everything will be done by the computer. Here no need of program, no need to write any program or no need to give any question, no need of question. Okay, you need not to give any query here or you need not to create anything. Okay, just you have to write the problem there. You have to write the problem. So what are the logic that will be given by the computer and it displays you the output. Okay, it gives you the output. Okay, so here you don't need anything. You need not to write any program, any questions, anything. Just you have to give the problem there. The logic will be added to the computer. Okay, and the output is displayed by you. That is a fifth generation language. So in this fifth generation language, artificial intelligence, all this comes, and nowadays, so humanoid robots, all those are used, and they will recognize your voice. They will work as you command them. Like those generations also came. Okay, next is the artificial intelligence. Okay, how many generations of languages? In first generation language, what it is? Binary code. Binary codes are used. In second generation, what it is used? Mnemonic codes. Mnemonic. Third generation, program. Okay, program. So fourth generation, we will give queries or questions. Queries will give. So fifth generation, we will give just only problem. They will give the output. Okay. So these first and second generation programming languages comes under low level programming languages. Low level programming languages. Okay. And third, fourth, fifth generation languages comes under high level programming languages. High level programming languages. Okay. Okay children, hope you all understood. I will show you examples of all these programming languages in the video so that you can understand and remember better. Okay. Good morning children. Today we are going to learn about language processors and generations of programming languages. So the language processors, language translators are assembler, compiler, interpreter. Okay. Next is this assembler converts the computer instruction into binary language, zeros and ones. Compiler, it compiles the high level language into lower level languages. So interpreter, it converts this high level language into lower level and assembly level, binary level languages. So next is generations of programming languages. Okay, what are these? In these two types, low level programming language and high level programming language. So in this low level programming language, first generation and second generation languages will come. And in high level programming language, third generation, fourth generation and fifth generation programming languages are there. See how many different programming languages are there. C#, C#, C++, all these are different programming languages. So first generation programming language is machine language. See, zeros and ones, only binary code in this. Second generation language, so here assembly code, object code. So this is the assembly code and it converts, using assembler it is converted into machine level language. So third is third generation language, C example it is, to add two numbers. See here, this is the code is written in third generation language, in C language. Next, fourth generation is, you have to give the queries. You need not to write any program. Whatever the output you want, that query you have to write. So SQL is the example for fourth generation languages. Next is fifth generation programming languages. So what I said, here you can give any question. See, here you can give the question and the answers will be displayed. See, like this. These are the examples. Example for fifth generation programming language. See, here question is given, who are my customers in Chicago. So the answer is displayed here. And what is the performance balance? Like this, some questions they will ask and the answer will be displayed on the computer. So next one, conversion of program in from high level language to machine languages, how assemblers and compilers will be used to convert that program. See here, first high level language in C or Java it is written and it is in the Fortran language. So using compiler they have converted into assembly language, and from assembly language this assembler converts it into machine language. See, zeros and ones. Okay, like this the conversion in the computer will happen. Thanks for watching.